I love my cats, but they also love jumping on my dining room table. And this requires a show of force by spraying them with the spray bottle. So, what if we remove the human action out of that and replace it with mechatronics?
My solution is the Automatic Cat Area Denial System, or the ACAD for short. The ACAD will sweep and search for objects within its user's specified range and spray it with water. Its actuators are two servo motors, one motor to control the firing mechanism, and another motor to control the rotating base as it sweeps. Its sensor is an ultrasonic sensor that uses ultrasonic waves to measure the distance, and that can be used to detect motion as well. While the ACAD is sweeping, the processing code will indicate its status by displaying the arming distance, the distance of any detected objects, and a warning message when there is a target detected. Right now, the arming distance is set to 50 centimeters, so the servo turret will shoot at anything that comes within that range. Out of range, it will continue rotating and sweeping for targets.
So, let's take a minute to explain some of this code. I chose to utilize the servo.h library because I needed snappier, accurate control of my servo motors to operate the firing mechanism. So, in the spirit of this project, I decided to challenge myself by writing the manual code to operate the ultrasonic sensor instead of using its respective library. I utilize the lessons I learned about timers and protocols to help me do this. So, how does an ultrasonic sensor work? Well, it works by following this manual protocol. The trigger pin outputs high for 10 microseconds, and then the trigger pin is outputting low. And this tells the transmitter to send out sound waves that the receiver can pick up once they bounce off an object. Then the echo pin is told to measure the time delay using the pulse in function. And this repeats every 10 microseconds. Doing so, this outputs TS, which can be used to calculate the distance, which can also be used to sense any motion. The biggest challenge was controlling everything simultaneously. The servos operate in milliseconds, but the sensor operates in microseconds, leaving a large time disparity between each action. Additionally, the two servos operate at different speeds, which will require different time delays. Because of this, using the delay function will cause stuttering during the operation and lower the accuracy of the sensor as the whole program has to pause for each action. So this means that I can't take sensor data while actuating my motors. My solution is to use the milli and micro functions to keep track of when any of these functions should be called in my loop. And this allows me to activate all three uh, independently.
Thank you for watching. This has been my ENME-351 final project. Now I would like to dedicate the remainder of this time to honor the servo motor that heroically gave its life testing the trigger mechanism.